the aim of today is how to work with unbalanced dataset. The challenge here is basically that sometimes we are not getting some satisfactory results from the machine learning models, not because of the model itself, but usually for also the data with which we have performed the training. Okay, for example, we are now working with, let's see, two different type of data set. The first one is an unbalanced one. Why I'm saying this? Because basically these data are coming from healthcare department, and this amount of data has different kind of label. So the false, for example, if the amount paid to date and, for example, the number, the minimum and the maximum number and so on, and this kind has been assigned as false from the department, or true. Okay, let's see. So this data set seems unbalanced. Why I'm saying this? Because, of course, the false values are 100 in this case, but the true ones are 19. So, of course, we can perform a training with this dataset, but at least we are not 100% sure that the results after this training will be successful. Let me show you also another dataset. This, of course, would be the ideal case. In this case, the same label is 50% false and 50% true. This would be, of course, amazing, but of course, working with real dataset is not always happening. So let's see how can we manage this into our platform, for example. Let's start, for example, with the unbalanced one. Okay, I've already created the workflow, and basically in order to detect the medical fraud based on the patient information, of course I'm retrieving the medical data. In this case, I'm retrieving the unbalanced dataset, for example. And then what I further do is the following. I have many attributes, but only some of them are correlated. So at first, I would like to set the role. In this case, I set the role, the label. This is what we would like to achieve. Basically, we need to classify and then to predict. Eventually, by adopting this model into the production, this label, if it is false or true. And of course, what I would like to do is, of course, to remove the correlated attributes. This could be, in any case, also an issue for a good machine learning model, because if the attributes are too correlated, then we cannot find any further correlation that could be also useful and then could help us achieve more satisfactory results. Let me at first run the script. Sorry, this workflow. Okay, perfect. Okay, so let's see the accuracy. Okay, well, the accuracy is fine. We are getting 90% for the predictive, for the true false, for example, and 98 for the true false. So let's say these numbers are not so bad. Okay, maybe for this category not. One thing that we can do in order to manage as much as we can this kind of unbalanced datasets that we have already checked by a proper visualization, or it usually when we are performing a first pre-processing and a first cleaning phase of the data, are also some further criterion. Usually the accuracy is not sufficient when we are dealing with this kind of dataset. So again, what we can check is the AUC that is able to let us understood basically the ratio. If we are getting more and more near to 1, then the classification is good. On the other side, if the same curve that you can see here in the red one is going directly down towards 0, then is worse. Now, of course, here we are talking about simple dataset. You can imagine this can be applied to every dataset, usually dataset at least that have a proper label. But you can see here, so despite of the accuracy, this is a better result. You can see here that we are getting more and more near towards the one, the perfect. Of course, we can increase the performances of this kind of model. At the same time, we can check, of course, the precision and the recall. All of these kind of all of these kind of measures could help us more and more in respect to the accuracy to detect, to work better with unbalanced datasets. So one thing that we can do is to try to get the proper measure in order to understand better how our machine learning model is performing. On the other side, if we are doing the same with the balanced one, of course, you can see here now the true false, for example, are worse than before, of course, but the overall performances are better in any case. So, of course, I would prefer this second one. And you can see also that in respect to the red curve is going before here, directly here at this level, directly towards 1. So it's better, of course, this model. Then, of course, then we need to check and to validate this with other data. Okay, so for example, but what if I have only this data set? Then how can I do it? Okay, of course, the first answer, maybe the most obvious one, is to get more data. And then trying to find maybe a more balance between your data, between your labels. Of course, this is not always possible. Then I can help you with a proper operator that we have also in AI Studio. Because, for example, let me check. Okay, let me do this directly with the unbalanced one. Okay, if I go here, I have also this parameter. This block. This block is the sampling one. One thing that you can do when you are dealing with this unbalanced dataset is trying to sample those data. Resample again in order to find more and more, in order to find a more balance between, let's say, the two parts. Basically, we are dealing with a binary category: is 1 or 0, is true or false. And how can I do this? Of course, I can choose different type of sampling. The most used one is the relative one, and I can check or uncheck. In this case, I've already checked this. The balance data. Yes, I would like to balance my data, and I can also try to stop the ratio between the true and the false, for example, like here, like this. Now that I've checked my balance data, let me maybe do it like this. Okay. Okay. Now things, of course, I'm checking in the accuracy, but now things you can see are getting a little bit better. Of course, we need to work better. Also, we need still to work better with this category, but the performances are getting more and more better. For example, if I check, okay, yeah, this is I think in my perspective, this is the most obvious chart because I'm seeing directly this ramp and directly it goes directly to 1. So of course we can work, we can deal with this sample. You can see here, I've already checked, I already searched for it into the operator part in order to try to balance the data, even if I'm not, even if my data source is not already balanced. Another thing that we can do, just to add one more point, is to eventually trying to work with different kind of models. So for example, here is used gradient boosting tree. Then of course, maybe within the auto model, I can check the basically maybe only a simple tree, and let's see what it happens and so on. But of course, when I'm dealing with unbalanced dataset, this is basically the first. Of course, the first thing that I'm doing is trying to arrange the things into the turbo prep part. But then after that, if I cannot do anything more, if I cannot achieve, if I cannot get any more data, of course, I will go directly with the balancing phase here directly, resampling the data. And then, of course, you can try different type of methods, of course. In any case, the results, as you can see here, they will be increased more and more. So basically, what we have done so far is to at first check directly the data, and then resample in case of need, check the different criteria, and in case latest point, if we are not able also to add further data, to maybe trying to test different type of models.